So we have the given problem, a to the negative 1, b to the power of 2/3 in parentheses, all over to the power of 5/4 times b to the power of 0 all over a squared times a to the power of -1/2 times b squared all to the power of 2, and this is all to the power of 3. This looks like a nasty problem, but if you follow me, then you'll be able to solve it or get an idea of how to solve it. So let me show you a kind of like the basics of how to solve it. It's not a perfect line, but yeah. So I'm gonna give a certain problem of x to the 1/2 all over 6 to y0 all over to x negative 3 y 1/2 over 2. So this is kind of like an easy alternative to this problem right here, except it's not to the power of anything. So what you'd first necessarily do is you would, since this is a y to the 0, anything to the power of 0 is equal to 1 even variable, so you'd get x to the power of 1/2 times 6, and since this is a parentheses and you so you're basically multiplying exponents, so this would be 6/3, so that's equal to x to the power of 3 all over, so you'd have x to the power of 6 over y, and since this is also equal, this is basically x to the power of 1, and as you can, if you know what, when you multiply this part other than the exponents, then you'll start to add, and you'll get x3 over x to the -5 and y. That looks kind of like right. And since you're getting -5, and since this is dividing exponents, you'd subtract the exponents, so you get x3 minus -5 over y, so that would equal x8 over ny. So this is our final answer. So feel free to pause me if you're a little bit more comfortable with solving this problem. So we'll get right into that. So we're gonna start to solve this problem. So we already know that anything to the power of 0 is equal to 1, so we can just say this is 1, and since anything times 1 is itself, so we don't really have to include this here, so yeah. So now we have to solve through this part, and that would equal to a -5/4 and b which would be b. So since this is a 2, 3, and 5/4, you can just simplify this into 5/6 all over a squared, and you first want to multiply through this. Instead of multiplying, you can just use the rule of PEMDAS. So you probably know what PEMDAS is. PEMDAS stands for, if not, it's parentheses exponents multiplication, division, addition, and subtraction. So these are the steps that you'd follow. So this is step 1, 2, 3, 4, 5. 5, 6. This is what you would follow in any algebraic equation or any equation that's similar to this. So since this is in a parentheses, you don't actually have to solve, but it's an exponent, so you do this first. So you get a to the negative 1 and b to the 4th. And you can't multiply a and b together, so you'd have to multiply a and b to itself. So you'd get a negative 5 over 4, b 5 over 5 to the power 5 over 6. And this would equal to a and b to the 4th. However, since this is a negative, you would always put this down because, let me just show an example. So if you have a negative exponent, so let's see, say you have x to the negative 1, since this would equal to 1 over x, or if you have a x to the negative 2, then this would be equal to a x over 2. So that's kind of like what you're doing here. Since you have a negative over negative 4 over 4, you put that down. You put that down, so you have a times a 5 over 4 for this part right here. So you actually have b 5 over 6 all over a 5 over 4 times a, and b to the 4th. So when you subtract this, you get, so when you subtract this down, you'd get, so when you add, okay, just count down. So when you'd add this together, since this is an add, you'll get, this would equal to, this would, so this would turn out to be, a 9 over 4, and this would equal to 1 over, since you subtract, like this, since it's division, you subtract this, and this would result in 2. So this would be a 9 over 4, and b, since you're subtracting, you get 19 over 6, but you also, but this is, remember this part, this is all to 3, and I'm going to be simplifying everything to 3 because it'd be simpler. So, subtract this, erase this part here. And this part, and once you get this, you have this would equal to, you'd put 3 over here and here, but it's obviously gonna be 1 all over a 27 over 4, and b, so it's 3 times 19 is equal to 57 over 6, but you can obviously simplify that into, can be simplified into 19 over 2. So once you have this, you can't have any radical denominator. So if you know what to do with, if you have a denominator of you have to multiply by the conjugate. So that's very simple. The concept to that is very similar to this right here. So this would, so this would equal to, what you have to do is you have to find the conjugate, or you have to multiply it all together. So you have to make sure this would equal to each other, so you'd get a, and what is 1 over, what's the closest to 8, so you pretty much get a to When equal to h is 7, or you want to get rid of the denominator of 4, so you multiply this by a, 1 over 4, and b, and you want to get rid of this 19, so you multiply by 1 over 2, and you do that for the numerator 2.
I'm glad you withheld.
Number 2, so that would be also equal to, so basically, so the denominator would be a 1 over 4, b 1 over 2, over